Okay, so we're starting section 2.3 part A. There's going to be a part B. Okay, that'll be the backside of the homework. You'll have the homework, both A and B, in your possession by the end of the period. But today we're doing operations with polynomials, just the part with sums and differences. But we don't say like sum and differences because sums can be positive or negative addition. You know what I mean? So you can add a negative, that really means subtraction, or you can add a positive, which really means addition, right? But we can say summing, meaning we can add or subtract positive, negative numbers. So that's why we just say sums. Now, a quick reminder that a polynomial is a function whose powers are positive integers only. Okay, so no negative powers, no rational powers, meaning no fractions on the powers, no decimals on the powers. So as long as that doesn't happen in the expression, then we're okay. All right. So example number one, I just ask, are the following polynomials? All you got to do is say yes or no. And if the answer is no, where's the problem, right? So what do you guys think for part A? Is it a polynomial, part A? No, it's not. Why not? Where's the problem? The power of what? -2, right? So this right here, your answer is going to be a no. Okay, so I'm going to put a power of -2. That's the issue. Okay, what about part B? Is that one a polynomial? What do you guys think? Is it breaking any rules? The powers on part B are a what? A 3 and a 2, right? Are those positive? 3 and 2? Yeah. Are they fractions? No. Are they decimals? No. Are they negative? No. So is it a polynomial? Yes. Is there a fraction in that problem? Yeah, a half. But the half is not a power. That's a coefficient, right? It's a number in front. So this is a yes. It passes all the tests, right? It's not, they're not negative powers. They're not fractional powers. They're not decimal powers, right? They're positive integers. What about part C? Now, this one is going to remind you a little bit to something you may have done in math 2. This is just a quick reminder. If I write square root of x, that's the same as writing x to the half. Okay, they're called the fractional powers. Cubed root of x is the same as writing x to the 1/3. Okay, if I were to write like fourth root of x, that's x to the 1/4. So look at part C. How do I write the cubed root of b? That's b to the what? Which one is it? The 1/3. Is 1/3 a positive integer? No, right? It's a fraction. So part C right here, the 12b squared, that's perfectly fine. Okay? But the 6 cubed root of b, that means b to the 3rd power. We can't have fractions. Okay? So I'm going to write no. And I'm going to say that the cubed root of b is b to the 1/3. I'm going to put no fractions on powers. So I'm just giving you the reason why it fails. Now, if this was just b to the 3rd, that'd be fine, but not b to the 1/3. Okay? So fractional powers come from radicals. Whenever you see square roots, it's a half. Cubed roots, it's a 1/3. Fourth roots, it's a 4th. Okay? And then this last one. And you might be able to do this one pretty quickly. Yes or no for D? No, right? And what's the problem with it? Where is it located? Is it, well, the fraction, right? But to be more specific, the fact that there's a power on the bottom, x squared on the bottom, really means it's a negative, right? That really means x to the -2, right? So if I were to write like 1 over x squared, that's really x to the -2. That means that this part right there is really a negative power. I'm just going to put negative power. So whenever you see a variable in a denominator, that variable has a negative power. We just don't see it. But if we were to move it up, it would be a negative power. Okay? So that's the problem right here. So on your homework, the first 4 problems, I think it is, they're just going to ask you, are these polynomials or not? And you just have to look and decide, like, all right, are all the powers positive integers? And if they are, then yes, it is. If you see radicals, that's usually a bad sign. If you see fractions with variables on the bottom, that's usually a bad sign. If you see negative powers, that's usually a bad sign, right? So you just got to say yes or no. I don't think they, let me see. Yeah, I don't think they need you to tell them why. I'm just writing down the why. Now, if I were to ask you for part A, or sorry, not part A, part B, bless you, because B was the only one that was a polynomial, okay? So they're going to say, if it is a polynomial, what's the degree on it? So only part B. What's the degree on part B? Remember, that means highest power. So yeah, 3. Okay? So you would write degree of 3. So I'm just going to put that right here, okay? I'm going to put degree is 3. If it's not a polynomial, you don't have to write degrees, okay? Because the degrees are only for polynomial functions. So I wouldn't have to worry about writing a degree for A, C, or D, just for part B. So your first homework that you're going to do, the first 4 problems, they're just going to say, are these polynomials? And if they are, find the degree. Just tell me what it is, okay? So that's the first 4 problems. Should be pretty easy. After that, they're going to make us add and subtract polynomials, the sums, right? Like they said, finding the sums. Now, the only thing that's tricky about adding and subtracting polynomials is usually the way they're written, okay? You're going to notice they're going to be placed in parentheses, right? One polynomial expression and another polynomial expression in parentheses. The only ones that are kind of hard, I don't even want to say they're difficult, but they might be a little confusing, is whenever between the parentheses there's a negative sign, okay? Because if there's a minus sign, that just means you have to distribute the negative carefully, okay? And once you do that, the rest is kind of the same for every other problem. So I can tell you that part A is a little bit more tricky than part B. Because notice part B, the 2 parenthesis sets, there's a plus in the middle. So I'm adding these. But for part A, I'm going to be subtracting them. And that requires a little bit more care. You don't want to rush through those. Okay? So we're just going to be simplifying part A and part B. And I think there's a part C as well. And then we're done. Okay? So simplifying part A. So I have the quantity of 3f plus 2 minus the quantity of 6f plus 5. And they just want me to simplify. So what I'm going to do is I'm going to distribute the negative. Anytime you distribute a negative, it changes signs of numbers, okay? So let me rewrite this. This is 3f plus 2, a minus 6f, and a minus 5. Because notice 6f and 5 were positive, but a negative is going to change their signs. Now I'm just going to combine my like terms. So I have 3f minus 6f, that's negative 3f. And then 2 minus 5 is negative 3. And I'm done. These problems are not meant to be difficult, but they can be if you're not careful. Okay? But they're not supposed to be difficult. You should get these right like 9 times out of 10, maybe even 10 times out of 10. Just be careful. Okay? Combine your like terms and stuff. So, like I said, this one's a little tricky because of the minus sign. Okay, but now notice part B. You might say, well, wait a minute. How can part A be tricky and part B not be as tricky? Part B has more stuff. Yeah, but there's a plus in the middle. A plus in the middle, when I distribute a positive, it never changes anything. Okay, so I am going to distribute the positive, but everything after that is going to stay with the same sign. So there's no way for me to really mess this up. Okay, so this is going to be 2k squared plus 5k minus 3. See how the 12k squared is positive? So I'm going to keep it positive. See how the negative 6k is negative? I'm going to keep it negative. And the minus 6 there, it's going to stay minus 6. It does not change signs. That's why we say that B is easier than A, because in A, I had to switch signs because I had to distribute a negative. Whereas for part B, I don't have to. Now just get your like terms and combine them. So 2k squared is a like term with 12k squared. So I'm just going to add those. That's 14k squared. Then I have a 5k minus a 6k. That's going to be negative 1k. Thank you. Oh, thank you. For some reason, I thought that was a delivery for somebody. But I just remember he said he was going to get me a bag. And then a negative 3 minus 6 is negative 9. And we're done. And that's it. Again, it's not hard. That's what I'm telling you. Like 9 times out of 10, you'll get it right. Like really, I think 10 times out of 10, just take your time. The biggest enemy of a right answer is when you're not patient, when you're just trying to get stuff done, right? You're just in a rush, and you're not being careful. You're adding things that you shouldn't be because you just didn't notice it, right? Take your time. All right. I told you guys many times I was not a fan of math in high school. Heck, I wasn't even a fan of high school. Um, but I definitely was not a fan of math because I was just impatient and I just tried to do everything fast, right? Just to get it done and get out of the way. And it wasn't until I got to college that I had to learn to slow down, do my work vertically. You notice all my work is done from top down, right? I used to do my work side to side. Any of you guys are side to side people? Yeah, I used to do it because I don't know. I don't know why. But then I realized I could never check my work because it never made sense because this equal that, equal that, equal that, equal that, right? Like in a straight line. And I couldn't tell what I did. So it took me getting organized, right? Writing things cleanly and just being patient, taking my time. So I gave us part C as like a tricky problem. Okay, I put a bunch of negatives in there to see if I can mess you up, right? On purpose. So not that it makes it harder to do, it's just you got to pay attention. Okay, so this last problem, we're going to do the same exact thing. We're going to distribute the sign in the middle. Notice I made it a negative just to make it a little bit more challenging. The negative will change the signs of everything in the second parentheses. So this negative 6x squared will become a positive. The positive 3x will become a negative, and the negative 2 will become a positive. But that's like the tricky part. After that, it should be pretty easy. So here we go. Negative 3x squared plus 6x plus 2. Sometimes people ask me, well, Mr. B, why does the second fraction or the second parenthesis change but not the first one? Well, because there's no signs in front of the first one. If there was a negative here, then I would have to distribute. But they don't put signs usually in the front. So that's why we don't normally mess with that. But now the second part, this is going to be a plus 6x squared minus 3x plus 2. And I think that's the hard part. From there, just combine your like terms. So I have a negative 3x squared and a positive 6x squared. So that's going to give me a positive 3x squared when I combine those. So that's positive 3x squared. And then I have a positive 6x and a negative 3x. So 6x minus 3x, that's positive 3x. And then a 2 plus 2, that's 4. And I'm done. This is your lesson for today. Tomorrow we're going to be doing multiplication. That can get kind of wacky sometimes, okay? But today we're getting rid of just, is it a polynomial? And then add and subtract them, okay? And that's all you have to do.